Hi, I'm Cheryl Leach. In this problem, we're asked to find the equation of a function whose derivative is 1 over x squared times e to the 2 over x power and passes through the point 46. Now, we've done problems like this before. However, the derivative that we're given keeps getting more complicated, which means we need more integration techniques. So let's go ahead and dive into it. I know that in order to find my function, I need to integrate my derivative. So my function is the integral of the derivative. And I know what the equation is for that derivative function. I have 1 over x squared e to the 2 over x dx. Now here's where it's getting more complicated. I need to find a technique to integrate this. Well, basic rules aren't going to work, and I don't think an algebra rewrite is going to help me either. But I do see some composition in this problem. I'm composing 2 over x and e to the x. It's a composite function. So let's try our u substitution technique. So again, a typical choice for u would be the inside function, which in this case is the 2 over x. Well, if I try to substitute it in right now, I'm going to end up with 1 over x squared e to the u dx. Again, I have a combination of u's and x's, which I don't want. I want everything written in terms of u. So let's see if I can find a relationship between du and dx. Well, I think the first thing I'm going to do is rewrite this in just a little bit. I'm going to write this as 2x to the minus 1. It's going to make differentiation a little easier. Du dx then is going to be a minus 2x to the minus 2 power. And then I can write du as minus 2x to the minus 2 times dx. Now, let's see if this helps in my problem. Well, the first thing I'm a little concerned about is that I have an x to the minus 2 power and a 1 over x squared. Well, I think I could fix that with a little bit of algebra. Let's rewrite du as minus 2 over x squared dx. They're exactly the same thing. So that makes me feel better about the 1 over x squared. But I'm also not matching up with that negative 2. Well, we've done this before. I can fix that by multiplying by negative 2 and also multiplying by negative 1/2. So in my integral, I'll multiply by negative 1/2. I'm going to have e to the 2 over x. I'm also going to multiply by negative 2. And I know that I'm changing positions here, but remember, multiplication is commutative. So I'm going to take the 1 over x and put it in this location times dx. If you take a minute and look at this, I've reordered things a little bit, but it's exactly the same thing. All right, well, what does that tell me? Well, I know now that e to the 2 over x can be written as e to the u. And this term, minus 2 over x squared dx, that's my du. So my integral now looks like the integral of minus 1/2 e to the u du. A much easier problem to integrate. I can pull out the negative 1/2, and the integral of e to the u is e to the u, plus my constant of integration. Integration's over, so I need to get my x's back. And I have minus 1/2 e raised to the 2 over x plus c. Now, if all I had to do was find the indefinite integral, I'd be done. But I'm trying to look for that function f that passes through the point 46. And remember what that means. That means that f of 4 equals 6. So I'm going to use 4 as my input. And I'm going to say that f of 4 equals negative 1/2 e to the 2 divided by 4 plus c. And that has to equal 6. Now I'm going to solve for c. Well, I'm going to have a minus 1/2 e to the 1/2 power plus c equals 6. And c is going to equal 6 plus 1/2 e to the 1/2 power. If you prefer, you could even write this as the square root of e. So 6 plus 1/2 times the square root of e. Now, I know this is an unusual looking constant. If you like, you can use your calculator and get an approximation for this. But to be honest, this is the exact answer. So let's go ahead and put the two pieces of information together. My function is negative 1/2 e to the 2 over x, and the constant is 6 plus 1/2 times the square root of e. That's my function with the given derivative that passes through the 0.46. I hope that was helpful. Thanks.